This is video number 2 on formulas of the topic refraction of light. Timestamps are given in the description box. You can watch parts of video if you are running short of time. In this video, I will discuss the lens formula and magnification of a spherical lens. Sign convention for spherical lenses. Convex lens. The origin of the coordinate system is the optical center of the lens. Optical center is the middle point of the lens. This is the midpoint. Usually the object is kept on the left side. This is the object. So the incident light will travel like this and hit the lens. So the direction of the incident light is the positive direction of the x-axis. So positive axis towards right. And vertically up direction is taken as a positive for the y-axis. Convex lens, the focal length is positive. To a convex lens, a parallel beam of light is sent. It will bend and meet at a point on the right side. And towards right is a positive direction. This positive direction of the x-axis, and this is the origin. So this focal length f is on the positive side. So f is positive for convex lens. For concave lens, again the origin is the optical center and positive direction is towards right. This is the direction of the incident light. So after refraction it will diverge, but it will appear to start from a point which is virtual focus. So the focal length here is the distance from here to the optical center. This is the focal length. It's negative for concave lens because the focus is on the left side. Lens formula for a spherical lens, it relates u, v and f. U is the object distance with the sign and v is image distance with the sign and f is the focal length with the sign. So the formula is 1 by u plus 1 by v equal to 1 by f, and with the u we have a negative sign. And magnification is how big is the image compared to the object. So it's image size by object size. The simplest object one can have is the vertical line or an arrow. So this is the object. An image can be inverted or also erect. Okay, so this size of the image is h prime and the size of the object is h. It's a linear size because the simplest object we are taking is a linear object. So magnification is h prime by h and it turns out to be v by u for a lens. And magnification is how big is the image. So this is 0.8 times h, then magnification is 0.8. And there is another information that the image is getting inverted. So it's minus because h is positive. This is the optical center. So vertically up direction is positive and vertically down direction is negative. So h prime is negative and h is positive. So this sign of the magnification has information that's an inverted image. So this lens formula and magnification formula, sometimes they have plus sign, sometimes they have minus sign. So how to remember this sign? For a convex lens, in most of the cases, the image is on the right side. So V is positive mostly, and focal length for a convex lens is positive, and the image object distance u is always negative because it's kept on the left side. So the terms of the lens formula is 1 by u, and then 1 by v, and then 1 by f. all these terms have to be positive for most of the cases. Since u is negative, I put a minus sign here and then add these two to get this one. So this is a lens formula. This way we can remember that the minus sign has to come with a u, because these are the terms 1 by u, 1 by v and 1 by f, and the terms have to be positive for most of the cases. And for most of the cases, v is positive for a lens and focal length is positive, only u is negative. So to make this u term positive, I just put a minus sign, and magnification is v by u, and this sign is plus to check that for most of the cases the image is inverted and v is positive. So v is positive divided by u is negative. So magnification is negative for most of the cases, which is true because for most of the cases object is inverted. So magnification formula will have only plus sign here for a lens. So this way we can remember the signs of the formula. So magnification negative means inverted image. For most of the cases, v is positive and u is negative and the image is inverted. So magnification is v by u, v is positive, u is negative, so this thing is negative, which is matching with the inverted image. So the formula is v by u. For a convex lens, the image will be formed at different places, and also the nature of the image will change depending on the object position. So start with the object at very large distance, infinity, and then bring the object near to the lens. So from infinity is brought to beyond 2f here. So when it is at infinity, the image is a point size object. So the object size is much smaller compared to image size is much smaller compared to object size. Here, as it moves in, the image moves from f2 to far away. From the focal length, it is moving to far away, and the image size is growing. But still, the image size is less than the object size when it is beyond 2f. So it still move further to 2f. The image will move to 2f, and the object and image size will match. This we already studied. Object at 2f, image also 2f, and the sizes are same. So magnification in this case is 1. Still move the object closer, this case. So the image will move farther away, and the image size is bigger than the object size. So whichever is farther away, that size is more. Before this, object is far away, so object size is more. After this case, image is far away, so image size is more. And once the object is moved to the focal length, it will produce two parallel rays. So the parallel beam will not form any image. Moving further inside, it will produce divergent rays, which will not meet on the right side, but projected backwards will appear to start from a point. So there will be a virtual image A prime B prime on the left side, which is erect and enlarged. So for the first 4 cases, where the object is moving from infinity on the left side to the focal point, just before the focal point, the image is forming on the right side, it's a real image and it's inverted image, and V is positive. So the lens formula 1 by u plus 1 by u equal to 1 by f with the minus sign of u. U is negative, so this thing is positive quantity. So sum of two terms, V is positive, is a constant, because for a given convex lens, the focal length is fixed. So sum of two terms is constant. So when the object is moving in, this term will go up, so this term has to go down, that means denominator has to increase. So image distance will increase. Object distance decreasing, that's object is moving close to the lens, image is moving away. So there is an inverse relation between object moving towards the lens and image moving out. This is for the object moving between the infinity to the focal point. Once it moves beyond the focal point, where the object is placed between the focal point and the lens, image is a virtual image on the left side, so V is negative. So in this formula 1 by u with a minus sign plus 1 by u equal to 1 by f, since V is negative, I put a minus sign and minus sign here. The quantities within the bracket are positive. So here it is, difference of two terms is a constant. Focal length is a constant, So term 1 minus term 2 is constant. That means if term 1 goes up, this also should go up. When the object distance decreases, this term will go up. So even this term should go up. That means this image distance should decrease. So object distance decreasing means image distance also decreasing. So there is a direct relation between the object distance and the image distance after crossing the focal point. So once the object crosses the focal point, if the object is moved from here to here, image also move closer to the lens. Before this focal point is opposite, when the object moves in, image will move away. It's an inverse relation. But once it crosses the focus, when the virtual image is forming, when the object is moving in, image will also move in. So this is a way to understand the lens formula. For a concave lens, there are only two cases. One, the object is at infinity, parallel beam of rays will diverge, but will appear to start from a focus, which is a virtual focus. And so this is a point size image of a object at a large distance. So h prime is much less than h. At any other finite distance, it will produce divergent rays. Projected parts appear to start from a point. So this A will appear as A prime here. So this is a virtual image which is erect and diminished for any position of the object at a finite distance. So for object at any finite distance between infinity and 0, V is virtual image on the left side, so it's negative. So the lens formula 1 by u with a minus sign plus 1 by V, I can rewrite as minus 1 by minus V. Quantities within the brackets are positive quantities. And focal length is negative for a concave lens, so put minus minus. 1 by F, put minus minus in the numerator and denominator. So this is a positive quantity. Again, it is term 1 minus term 2 is constant. That means there is a direct relation between the object and image movement or distance. So when the object moves in, image also move in. So there is a direct relation. So the object is moved from here to here, image also moved to closer to the lens. Magnification is the image size by object size. So its image size is h prime and h, and it's a real number. So this real number can vary from 0 to infinity, and it can also be negative, so 0 to minus infinity also. So h is positive, this object, and the image is like this, then h prime is negative. So magnification is negative. But if you have a virtual image like this, then in that case h prime is positive, so magnification can be positive. So the meaning of magnification between minus 1 and plus 1, that's magnification is a fraction. It can be positive fraction or negative fraction. In this case, h prime image size is less than the object size. So it's a diminished image. Between 1 and infinity, enlarged image. Here also enlarged image. But it is inverted because magnification negative. Here it is erect because magnification is positive. And whenever the image is erect, it's a virtual image. And inverted image is a real image. So these are the different cases. So from 0 to 1, image is diminished and is erect and virtual. Between 1 and infinity, image is enlarged, erect and virtual. Between 0 and minus 1, it's a diminished image, but inverted and real because it's still negative here. And between minus and infinity, it's enlarged image, inverted and real. So magnification being a fraction means the image size is less than the object size. It's a diminished image. And magnification being a negative means it's inverted image. power of the lens means how powerful the lens is. Consider these two lenses. One is a, say, fat lens, another lens is a thin lens. So to this lens, if we send a parallel beam, it will converge at a point here at focus. For this, if we send a parallel beam, here the amount of bending is less, so it will focus at a larger distance. So this is f1, this is f2. So f1 is less than f2. But this lens is powerful because it's bending the light more. This is the amount of bending here, and here this is the amount of bending. Okay, so when the focal length is small, the lens is more powerful. So there is an inverse relation between the power and the focal length. So power is defined as 1 by f. And if the focal length is measured in meters, unit of power is 1 by meter, which is called diopter in SI units.